Hey everyone, it's truly honored to be here today and present machine learning work from DevSeed. And let's go ahead. And today I'm going to be talking about satellite machine learning in the cloud and how we implement these machine learning algorithms in the cloud and solve like specific case study basically. So I'll walk you through. So let's look at this satellite image, and you see like this blue color, like river network. And then we have like a bare earth look agriculture land. This image is taken by Sentinel-2 in Irrawaddy Delta in Myanmar, right? And so if you have a high resolution satellite image, you can zoom in. There's millions of smallholder farmers working in the land, and there's a fisherman, right? And millions of people like order this landscape and seascape. And we have so much Earth data nowadays, and how we're going to combine those with like real data from the ground and actually solve the problem that can direct people to make a better decision like on our landscape and seascape, right? And also like monitor the climate. And okay, so we have a machine learning merged, and we wish there's like some kind of like magic. We have Earth data from one side, and then we can output the useful and helpful data layer to the decision maker directly, like who can use that data to make a better decision or policy making, right? And there's no such thing, right? Like this is more complex than that. And so we have multiple users who are going to use this data layer for agriculture, for environment, for climate change, and for like, like monitor the hurricane, volcano, right? Like so many use of the data layer, and how we're going to trace back and to search and select and process a satellite image. Like we have open source data, like we have Landsat, we have Sentinel, we have, like all these models, and merging commercial satellite image and DG, right? And Planet and Airbus, like which band we're gonna use, which image we're gonna use. There's so many questions to ask here. And to ask those questions and to produce a useful data set, what machine learning algorithm we're gonna trying to build and to solve this problem, right? And at DevSeed, we have in machine learning, we have unsupervised machine learning, supervised machine learning, and reinforcements machine learning, right? And in DevSeed, today I'm just gonna talk about supervised machine learning. We have fully automated machine learning pipeline, like ideally, right? And semi-automated machine learning pipeline that requires some kind of like human input, either like cleaning the data or validate the data, right? And so let's go to the next. It's not working. Okay, so fully automated machine learning, we have here a tool we use to tracking the urban change from the space that we built with Radiant solution. And automated machine learning, I am going to go a bit of technical side of it now. And we have segmentation and object detection, right, in the supervised machine learning sides. And what is segmentation and object detection, right? And go here, look at your right sides. We have a cat and dog, and each pixel that we classify belong to dog goes to the blue shape of, like we call polygon, right, in a geospatial site. And then all these pixels belong to cats is go to this red box, right? And then we have object detection, which is not telling exactly which pixel belong to what class, but we basically tell the location of boxes, right? And those two is coming down to the machine learning on satellite image. We have, building footprint. We're looking at, and we can using object detection to detect like how many cars on the roads, right, and how many buildings in this city. And another one is image classification we have, and that is the simplest machine learning we can work pretty well, right? And in DevC, we basically, segmentation, we are looking at, for example, the building footprint, right? Building footprint is we have satellite image, and then we have labeled data, and we paired it up and to train the machine learning, to train the segmentation algorithm. And again, we have, for example, road network. We have a satellite image, and we have labeled road network, and we paired it together to train the segmentation again. So we can predict on the unseen satellite image, fed it into the trained machine learning pipeline, right? And just output the building outline or road network. And another one is object detection, like, for example, counting the building, counting cars, right? And this work, like we built with, we kind of built it into special economic zone for World Bank to kind of monitor like how many new buildings come out from certain region to kind of monitor the economics growth in that area, right? Okay, so come back to Urchin again. So we are tracking the urban change from the space. This is like kind of pipeline, like can building machine learning, right? So probably a little bit too distracted here with Jeep, but one side we are pulling data from OSM, and on the other side we have machine learning like predicted on the satellite image, and we have building outline from the machine learning. So those two sides, we can compare those OSM data and machine learning prediction on the current date of image, right? And by compare those two, we can see like which area of OSM is likely out of date, so we can guide a human mapper to map this area. And also, like, it's not only for building pipeline, like we're thinking about like building in road network, so we can direct human mapper to go to map the unmapped areas of like roads. And again, this tool is we can build many machine learning algorithm, as many as possible, right? Like we can tracking the like agriculture productivity, as well as we can like, like building green space, urban monitoring area. And again, here is another machine learning pipeline we built is image classification, which is we built a high voltage grid in Pakistan, Nigeria, and Zambia. This image classification is taking in the high voltage tower satellite image, like we selected for training data, right? Like then we train this machine learning. And basically, then we have like the whole country of image tile, and like going through this machine learning and output, like, like, oh, if this is like, this image can turn the high voltage tower, then our human mapper, like our professional mapper at DevC can go in and kind of trace the high voltage grid. And from here, you can see that this all this pink box is the prediction from machine learning, and this is our human mapper, right? Like a real speed, like just link all these high voltage towers together and map, and this is before and after the high voltage tower mapping, and we have high voltage grid for three different countries. So come back to this fully automated machine learning pipeline and semi-automated machine learning pipeline. And okay, so machine learning pipeline take in training data and run on this algorithm like we built and spit it out the data layer we want the user or like we want to push to another pipeline, right? And as I mentioned, there's so many satellite image, like which one to use. There's required search, select, and process. And there's even no like machine learning ready data set, right? Ready yet. So at DevC, what we did was build another tool, right? Like label maker. So go back and check out pips install label maker. And label maker, what label maker does is pull down the OSM data as a label. For example, like image segmentation, right? Like road network, we pull down this road network from OSM, and another side is like you can have your customized satellite image, or you can have pull down the satellite image from Mapbox or DG map satellite AMI, and kind of like pair those label data together with satellite image, and just get ready to get this ready to go training data set for one of your favorite machine learning, right? Either like build with TensorFlow or MXNet, or CNO, PyTorch with Keras or not. And then we run a Spot instance, and yeah, if you haven't tried Spot instance, go ahead and try it. And that is kind of like it's a very cost-effective way to run this big machine learning algorithm and models on the cloud, right? And my favorite is deep learning AMIs, either like with Ubuntu machine or Linux. And don't forget to turn on the cloud watch. And then after your model train and predicts down, the machine gonna shut down that itself, right? You don't need to watch it. At DevC, we have opened up all our machine learning tools and pipelines you can check on. And again, we have label maker, we have Skynet data, we have Geodex, and we have many other open source tool. You can search or process the satellite image, and as well as get this ready to go machine learning training data set. And we have pipeline like image classification and segmentation and object detection. And check out the label maker. We have many examples like get you to start with. And let us know, we are building more open source tool, and if you find like our tool useful or not useful, anyway, just let us know, and we are gonna update it and maintain it, and for a better use for you. Thank you.
So just press it forward, this one?
This is next.
Okay.
And this is go back, and this is the laser.
Thank you, Mark Fagan here. My presentation, I don't believe, will be quite as technical. It'll be more on the sort of the business sides of things. But let's just move on. This is still your slide. So we're a San Francisco-based company. We've been in business for 3 years. We're in Menlo Park, just south of San Francisco. Presently, we have 153 employees. They're primarily data scientists and AI engineers. One of the premises of our company is we're data agnostic. We believe that this explosion of satellite imagery that's coming available on the Earth is really is diverse and is completely necessary relative to at least the markets that we serve. We are not bound by any particular sensor, if you will. We work in both the commercial spaces, but as well nonprofit. We've been a relatively quiet company. Haven't done a lot of media presentations or and the like, so you might not have heard of us. And I will say that we have been somewhat consumed by one of our primary customers, which is what you're going to see here today, which is Bloomberg LP. Bloomberg is the largest financial data company in the world, and we've been working with them for 2 years. And but we are not relegated to just the commercial markets. The other point I'd like to try to make is we, over the 3 years, we've basically gone almost 100% convolutional neural networks for our machine learning. We still have, if you go to our website, we have some free products. One's called Land Viewer, and we do on-the-fly spectral indices, super simple mathematic algorithms that are more sort of a sexy presentation than necessarily our core business. And I will say there's a disclaimer. While it does say it's 100% convolutional neural nets, we spend an exorbitant amount of time, as Nana was, I think, also alluding to, is training and indexing. As a matter of fact, we have some quite funny stories, especially in the agriculture industry, of the challenges that we face to do the proper training. And one of the use cases I'll show should demonstrate that. And the other disclaimer I'd say is we are 100% Amazon. Everything we do is on Amazon, literally, other than, again, the disclaimer that very often the engineers want to get their hands on some fun gaming GPU processors to fool around the office and do experiments and those types of things. But we try to ask people not to do that. But our storage, CPU, GPU, everything, our presentation to our end customers is 100% on Amazon. So 3 use cases, just very simple, if you will. The first one is we're using the Sentinel-1A and 1B, European Space Agency's synthetic aperture radar satellites. We actually do our training in concert with the Sentinel-2 as well. I can go into more detail if people are interested in how we do that. And I'm just describing that the state of the art right now for commodities brokers and futures brokers in the United States is relying on statistical data that's self-reported by farmers that's extrapolated, that typically is a result that's 3.5 to 4 months long after harvest. So it's a big challenge to identify what the production rates are. And we're starting with just production rates, but we're also going to have the yield based on spectral indices as well. We're combining, so we get the true numbers. But to have that at a high accuracy and high cadence is difficult to do. The present methods today are, like I said, statistical extrapolation. The timeline is months after harvest. Cloud cover is a big problem. And the cost of satellite imagery, up until this point, has been almost prohibitive, especially at higher cadence, and the kind of resolutions you would need to use optical. So the solution that we've developed is synthetic aperture radar using, again, Sentinel-1 data. No cost to us. Earth on AWS is, we have, all of the data sets going back now. I'm trying to recall how many years now, which is great for us to do back testing of the information against historical data that actually helps inform our training. And what we're doing right now is we're measuring every crop in the United States by type, by what we call climate zones, by the season for the entire United States every 7 days. We could do it every 5 days, but we're doing it 7 is the cadence. And we don't have any issue with the cloud cover, obviously with synthetic aperture radar. It's not to say that doing INSAR is easy. We've been working at it for almost 2 years, how to optimize it, how to synthesize multiple data sets to get our baseline. But it's proven to be an extremely successful product. We actually originally developed it in the UK, and we verified it with, again, back testing of a lot of historical data. And you really can't beat the source of ESA's product. So it's a new and novel way, and for the billions of dollars that are spent on futures and commodities markets, it's a remarkably different product. So actually, you're looking at the UK here. So this is a graphic of the result. So it's a first of its kind financial data sets for commodities, futures, derivatives, swaps, the whole works. Very complicated world in financial. And it's not only for just the people trying to make money off of trading commodities. It's also, what we found out is there's logistics issues. Seed manufacturers need this data, processors, pesticide companies, manufacturers, to understand what the kinds of products that are being produced at what rates at a very high cadence and accuracy is truly important. And we do have some conversations. And we have a 12-person group who does just agriculture. There are some conversations with the USDA. I've not been part of them. But I know that we are trying to do some things with other entities beyond the commercial entities. Second one is, again, right now driven by the financial markets. And the challenge is that with all this fracking occurring in what we call wildcat wells, it's virtually impossible to know who's building what kind of new oil or gas wells where. There's 1.6 million plus in the United States right now. And the best methods are humans who go to courthouses and find permit information and drive around in trucks to guess, what's happening with the number of oil wells. There's another method. People are trying to measure the shadow rate of downstream of oil storage tankers, which has nothing to do with gas, and do a statistical extrapolation. But that's months after the fact. So right now we're doing it on a monthly basis. And I should skip up to it. But right now, the present methods are very poor, and the costs are extremely high. In this case here, we're using optical imagery. We're doing this with Airbus in a combination with Sentinel. Airbus for the actual high resolution, we're using Pleiades data that we're doing the training on and recognizing the change in the equipment. And so what we basically do is we say, with this image, by this training, we know that somebody's just bulldozing a new pad. The next step is somebody's drilling it. The next step after that, they put in these pump jacks. After the pump jacks go, they frack in 1 or 2 days. We know by ponds that are associated with fracking, waste products basically, where it is in its life cycle, and we create a proxy of what the production rates by the 1.6 million wells, which is a much higher, much more accurate result for, again, the financial markets who trade billions and billions of dollars on this. We do have issues. We are doing a large error with Airbus. There are challenges with respect to the tasking and doing that, even on a monthly basis, but I think we're good on that. And cloud cover is still an open issue. And some of the training issues with some of the equipment's complicated. One of the beauties, obviously, about neural nets is over time they just improve as we continue to do labeling, as we see anomalies in some of our data sets. We did a lot of that in California with respect to water conservation issues. And so this is basically a little bit hard to see, but the image on the far right is actually 3 pump jacks. That's sort of the state of the equipment there. The image to that lower left is just showing the different kinds of equipment associated with a different production life cycle stage. And the image to the left is probably impossible to read, but that's a representation of the 1.6 million wells plus happening in the United States. Again, it doesn't have to just be the financial markets. Actually, it's interesting. We are getting an awful lot of people who've been doing it the old-fashioned way, who are becoming, it's a very complicated business deal, but they're becoming our partners where we're providing this information to even for the markets that they serve, like the people who are the actual equipment operators or how leases are being sold. It's a very nuanced, very complicated space, but it's not just for the financial people. And I'm sure there's plenty of government entities and nonprofits who probably like to see this information as well for their own purposes, not to mention environmental issues. So again, 100% on AWS. Again, we've been doing this processing now, United States, UK, Ukraine, oddly enough, other places. It was Spot. The Pleiades data, as I mentioned before, is a 50 centimeter resolution. What we're doing with Spot is actually we're creating these time series where we can get this at a much lower cost and higher cadence, and we actually can do these, see where these new roads are being built, or where all new, these tailing ponds is what they call them, because right now fracking has gotten so efficient that usually an entire fracking operation can be done in 2 days, is how fast stuff is happening. And we just, Pleiades can't be, tasked that often. But if something was spot and we see these trends, we actually have a proxy relative to the fracking stage. And as well, the GPU and CPU processing, the neural nets is done in Amazon. And I already mentioned that last point relative to this use case. And this one is quite a bit different from those first two. I guess the best way to describe it is for financial institutions, again, Bloomberg, and this isn't just Bloomberg, this would be the IMF, this would be the United Nations, plenty of organizations have a real challenge, especially in certain countries that don't want to properly report their gross domestic product. And so in this case here, we're using, we have this problem of taking imagery worldwide at a monthly cadence and being able to analyze the intensity of night lights, which is a proxy when properly back-tested over multiple years against the IMF reporting, International Monetary Fund, sorry for the acronym, to really sort of align the algorithms so it can get quite accurate. And we've got these complicated ways that we're breaking down the economic zones to do quite finite analysis, but ultimately it's at the country level down to something called administrative districts. I might have a map I don't recall here. We're using NOAA's MPP satellite. And presently, there's been an issue with basically, I'll show you some of the challenges, is reflectance that happens with water and ice, and cloud cover masking has been a huge challenge for us. It's taken us months and months and months of work, and to be honest, not to be too critical, there were some, let's say, anomalies in NOAA's data that we discovered and had them fix that caused some issues for us over a period of time. But they've been great ever since, and the data's been completely consistent. So what we're doing is, the solution in this economic analysis is right now just a once a month product. It is literally the entire world. And we have dealt with the cloud cover issues, and the cost, again, from NOAA is just, it's fantastic. So I hope you can see this imagery. What you're actually seeing there is not the nicest imagery with respect to the image on the far right is, both of them is Aleppo. And you can see what's happened over a very short period of time with what's happened with the night lights intensities with all the warfare activities. It's a little hard to read what's down below. There was that's every month some indices that we have when we first were doing the initial studies. I don't have a graph that shows how this is all tied to the back testing of the actual reported IMF data. One of the big problems that's occurring in the world is certain countries, i.e. China, Russia, North Korea, have actually falsified their gross domestic product numbers typically, and that's one of the things that people are very concerned about in these types of analysis, and that's where this applies beyond even just the, the strict, commercial financial markets, if you will. Big challenge for us. This took us, I'm not exaggerating, about 18 months to figure out how to deal all this masking. Really, really difficult. Huge numbers that we're crunching at AWS. That's the last product that we have associated with this. So again, 100% of the cases on AWS. It's our largest data set to date. We've been working with AWS. It's been super great from a technology standpoint, how to optimize some of our proprietary methods, and optimizing how we're dialing up and down these services as we do these very complex analyses. And we're just launching this in two weeks, and we'll actually have a live version of this running. If anybody knows what Bloomberg Terminal is, it's the terminal all the financial brokers have. And you can see, well, we're starting with just China. It is the free product anybody can use, but anybody can purchase the thing worldwide, and I'm pushing my team to actually create a website that just shows this in general. Just for anybody to casually see what these types of information are. We're working quite closely with the University of California, Davis on some very unique economic if you will, breakdowns of zones that are important to financial analyses. And again, as I said before, I can only imagine the IMF and other public agencies would be consumers of these products. We just have been focused primarily at this point to Bloomberg. So that is the conclusion of my part of the presentation. And I'm not sure if Joe or whoever is emceeing this, if I guess there were some opportunities for questions. Yep.
Great, thank you very much, Mark. If anybody has any questions for either Mark or Nana, please just raise your hand. Either myself or Jennifer will bring a mic over to you. And here's the first question.
So you cited a number of open public sector data sets from government agencies. I'm wondering if you know of any opportunities for data products from government to actually include labeling or training data, or if there's maybe some investment government could make in furthering some of their data products to do that, you know, how that would be valuable to companies like yours.
And I presume that was to me?
Yeah, go ahead.
To be honest, I don't know the answer to that, but that is a very interesting question and something I would be very interested to pursue. Better labeling data just can improve life for everybody, including ourselves. It's not something that's making us, rich to do that component of it, and it just makes sense. And as well, other data relative to, again, backtesting is huge for us to improve the accuracy of our results, and what other data sources are open that we can access to do that backtesting would be a huge benefit. And the last one is just some of the historical data that helps us with NDVI, another spectral analysis, to combine that with not just the measurement, but the yield production rates is another source we're looking for.
I think we need to go to the stage because there's
Okay.
live streaming.
All right.
Any other questions? One in the back and then one here.
All right, hi. So the question for both of you, I'd be interested to know what are the biggest blockers for the workflows that you sort of talked about? Like what is the biggest piece that's holding you back from doing your work better? And then sort of what can be done to get rid of those blockers or sort of alleviate those pain points?
You want me to go ahead?
Go ahead.
From a building machine learning pipeline perspective, I think the biggest blocker is definitely from the training data set. Like currently we're seeing, especially like how to pull a higher quality training data set together, right? Like from satellite image itself, and also how we're going to have a human validate the data set and when it's better to do it, right? And again, it's going back to how we're going to improve this machine learning algorithm to predict a better, more accurate and or complete data set that is going to be useful for user. And when we're going to build a pipeline from the human side, human validate and push back to the machine learning, and then machine learning can do a better job of predicting the data. So I think it's from the training side. But yeah, I have a few colleagues over here, so probably they can jump in, if there's any blocker that I haven't seen yet.
I would just expand on that maybe with some funny anecdotes. So we started with just doing the Midwest of the country with corn, alfalfa, different types of wheats, 5 different kinds of wheats, cotton and some others, and having these poor kids, college kids, getting in a van and driving for 7 days and trying to figure out what kind of, different kind of wheat stuff. It's really hard to do. And what we discovered is we're just going to have to continue, because of the season changes, keep on doing that over and over again. And it's going to get more complicated in places like California, where you have such a diversity of the types of crop species, if you will. And the other is, I guess, we probably have not taken advantage of some of maybe the open source methods. We've built everything ourselves with respect to neural nets. And Basically, there's a bit of a learning curve for our engineers and a lot of experimentation that goes on for them to really figure out what's working and what isn't, and then go and validate that with, again, the back testing or the what other data sources we can from a ground truthing standpoint. So I think those are sort of our two biggest ones that we're dealing with.
Great, thank you. And I'm going to take a little bit of organizer prerogative here and somewhat help provide an answer to some of my own question. So I don't recommend this for anyone else in the room, please. But I feel we'd be remiss if we didn't mention some customers doing work around this space, like SpaceNet, which is a collaboration between Radiant Solutions, NVIDIA, and CosmicWorks that are creating labeled training data sets for groups to work on. There's also Functional Map of the World, projects like XView, all that are available on S3 for customers to work with, and tools like SageMaker. And in fact, there's another customer of ours, Radiant Earth, just at the end of last week that held a session aimed at figuring out how to build labeled training data sets for developing context problems, and specifically around land cover classifications and land change maps. So there's a lot of work going on in this space, and hopefully we'll see more. And I think those are. Go ahead.
So this question is for Mark. I've seen companies here doing agriculture predictions based on optical data, image data, and cloud cover is a big issue. And using INSAR data, have you guys compared to their results? Who
Sure.
win?
Yeah, so the UK is really what pushed us. I don't know how many people spend time in the UK, but it's raining all the time. So we started with, we did three things. We actually used DG data. So we were using Worldview 4 as one of the data sets we were contrasting with. The other one was we were using Sentinel-2. And we were using Sentinel-1. And we had always assumed that we would not be successful in just using the INSAR. And again, as I mentioned, we worked at this for a very long time. And the UK has really good data of historical data sets and proved that the INSAR stuff, from a resolution standpoint, if you do the proper synthesis, it's not the resolution that's straight out of Sentinel-1 or 2. Now you have to synthesize it to get to the higher one. So we actually have that challenge. We're monitoring all the mines in the United States. And we're actually, in that case, with TerraSAR, with Airbus, the mines are so small we can't even do it with Sentinel-1. But Sentinel-1 is proving to be the least expensive, and it's sufficiently accurate for our purposes. As I did mention, we want to overlay it with more of a statistical analysis on the optical to optimize the yield by understanding the spectral indices. But that's just a second step. And the most consistent one will be Sentinel-1 SAR.
Great. Any additional questions? We've got time for a few more. All right. Well, thank you very much. Thank you, Mark. Thank you, Nana.
Yep, thank you.
That was very informative. Please take a moment to give us your feedback from the mobile app. And our next session will be making sense of remote sensing, and that will start at 3:55. So looking forward to seeing you back here. Thank you.